All right, good morning or good afternoon, everybody. How are you doing today? We're going to go over section 9.3 here in a minute. Just want to kind of review here our weekly schedule. Everything is working out good. This is section 9.3, Thursday. This is going to be, I think this is going to be slightly a little bit longer than the other ones have. There's a little bit of information in here, a little bit more that we have to get through. So it's kind of helpful that we're off on Friday. There'll be no video or assignment then. Monday, come back, and then section 9.4. So there's only 4 sections. Well, we didn't even do 9.1. So there's only 3 sections in chapter 9, 1 in chapter 8. So not a ton of material. Tuesday we'll review, go over chapter 8 and 9, kind of a little bit more details on the test. Wednesday, no assignment. Okay, give you time to finish that. And then Thursday will be the chapter 8-9 test. Posted at 7, similar format. Posted at 7:30 a.m., submitted by 9 a.m. We'll go over a little bit after that then. Exam, we'll try and finalize the exact time and day of the exam, which will be the following week. We need to get that done by May 15th for that. Okay, and so when we're dealing with matrices, I'm going to go in. I need to cover a couple real quick things here. I'll go ahead and X me out. A couple things here before we get into this next section that are going to come up. You on your calculator, there's a matrix function. Normally, I give a no calculator test, no graphing calculator, and a graphing. That's not going to be very logical to do at this point. I'm not going to do it. I'm just going to give a calculator test, but there'll be some conditions on there that you have to really show your work. So you make sure you understand these, because calculators will do the multiplication, they'll do the addition, they'll do everything for you. And there's some cases where you absolutely need to use your calculator, which we'll get into for today and Monday. But for a case here, so like if I have, and this is not on your guided notes, so just pay attention here. So let's say A is a 2x3 matrix, so 3, 2, -4, 6, 1, 0. And B is a 3x4 matrix. So let's say 2, 1, 8, 7, -3, -2, 0, 1, 1, 4, 2, -3. All right, let's say A times B equals C. First of all, is that possible? A is 2x3. Okay. B is 3x4. So since the middle dimensions match up, we do get C, which would be a 2x4. So technically, you can come in and you can type this into your calculator. And I'm not going to go through all of some of the part that you need to know. I'll go through, but some of the part we don't need. I'm not going to go through how to do all that part, but you'd have to go through. Here you have to edit it, and then you'd have to type in, and you'd have to say A is a 2x3. And you should have done this enough last year that you are familiar with this. And that's -4, and then 6, 1, 0. And then you'd have to put in matrix B. And that was a, what do we say? It was a 3x4. And I got 2, 1, 8, 7, -3, -2, 0, 1, 1, 4, 2, -3. I hope I entered those all correctly. It's easy to make a mistake. Now, if you're multiplying those two with your calculator, all you got to do is hit matrix A. I don't even need to hit times, because if you write them next to each other, there'll be a multiplication. But I'm going to put times, and then I go down to matrix B, and I hit enter. And you get a 2x4. There's your answer. Actually, I hit it twice, so it came up twice. So let me just do that again. So hit second matrix A times matrix B. So your calculator will do all this for you. here's what I'm gonna have to do to kind of make sure you understand and know what you're doing. I might just say, so since this is C, I might just say, show me your work and find C21. Well, what is that? That is the position, that is their second row, first column. Okay. So you're going to have, we said it's a 2x4. So we got 1, 2, 3, 4, 1, 2, 3, 4. It is this one right here. So you're going to have to know how to find that and how to show me that. Second row, first column. That means you take this row times this column. And so you'd have to tell me that C21 would be 6 times 2 plus 1 times -3 plus 0 times 1. Well, what is that? That's 12 plus -3 plus 0, which is 9. See, we got 9 in that column or that spot. So you're going to have to know how to detail that. So instead of saying find the whole thing, I might just say find C21, and let's just say find right here. What would that be? That would be first row, third column. Find C13. That would be first row times third column. So which would be 3 times 8 plus 2 times 0 plus -4 times 2. And then you need to show this. 24 plus -8 looks like 16. And what do we get there? 16. So this is kind of a workaround, a little bit of a compromise. You ought to use your calculator. Yeah, technically you could type it in and figure out what those answers are, but you'd have to show me the values to get that. Okay, you can't just say C21 is 9 and move on, or C13 is 16. All right, this is still not on your guided notes. A couple other things that are going to come up and we'll talk about in terms of things we already know. We talk about the multiplicative identity. In regular multiplication, that is the number 1. The multiplicative identity is what times a number gives me back the same number. And that's 1. And this is so common sense because you've had it for so long. And so 6 times what gives you back 6? Well, you know it's 1. -4 times what gives you back -4 is 1. So the 1 is a multiplicative identity. We're going to talk about something called the multiplicative inverse. Well, the multiplicative inverse means what? Let me start with 5. 5 times what equals the identity? Okay, so we always want it to equal, I spelled that wrong, identity. Why am I spelling that wrong? Okay, I'm having a little brain fart here. Identity. I'm missing a T. I spelled it wrong. Identity. This is awful. Spelled it wrong again. Sorry. So what? 5 times what equals the identity? Well, that would be 1/5. 8 times what equals the identity? That's going to be 1/8. -4 times what equals the identity? That's going to be -1/4. So if for A, for any number A, 1/A is the multiplicative inverse. Okay, so I just wanted to kind of hit identity, what the identity is and what the inverse is, because we move into this section. Now, if you take a look at your guided notes, if I have a 2x2 matrix times a second matrix, how could I figure out what that matrix is to equal this? Okay, so kind of working backwards. Now, you can't just like normally, if this was 2x equals 6, you divide by 2, and you'd say x equals 3. We can't divide by matrices. Okay, we cannot do that at this point. And we don't have any other methods at this point. Some of you might say, oh, use the inverse. Well, we haven't even talked about the inverse, so that's not on the table yet. But there is a way to figure this out. If you just think about matrix B as 4 elements, I'll call it A, B, C, D. Would it have to be a 2x2? So if this is a 2x2 and this is a 2x2, does B have to be a 2x2? Well, the middle dimensions have to match up, so that has to be a 2. And this is the first and the last dimension of our two ones we're multiplying together. So yes, it would. All right, I'm going to set this up. We're not going to go through the whole thing. I kind of let you finish that. So here is this times this will be 2a minus 3c. And what does that one have to equal? Okay, if we do this per se, first row, first column has to equal negative 23. Now I'm going to move down here. And what does this row times this column have to equal? 6a plus c has to multiply together to equal negative 19. If we look at this right here, what do you got? We have a 2 by 2 system which we could solve. Now I'm going to kind of restart, so I'm going to get rid of that so it's not as confusing. If I do the first row times the second column, that is 2a negative 3 plus negative 3 times d, or just minus 3d. What does that have to equal? That is equal negative 22. And then this row times this column has to equal 14. And so you get 6b plus d equals 14. And you could solve those separately, okay, to figure out what your A, C, and B and D are. So there's a way to kind of go about a problem like this one. Okay, got to use a little bit of ingenuity, but we can figure it out. All right, let's move into section 9.3. They talk about verifying the multiplicative inverse, finding the inverse of a matrix, finding the inverse of a 2 by 2, and here's going to be the big one. We're going to use matrix inverses to solve systems of equations. Okay. But we got to do a little bit of background first. All right, let A be this 2 by 2 matrix. Now it says find matrix B such that A times B equals A. This is kind of like the case where I want to end up with the same matrix. I want to end up with, this is going to be our identity. Okay, we talked about this in regular earlier. Identity. Why can I not spell identity? Or am I spelling it wrong? Okay. This is going to be our identity. All right, I am going to do something here for a second. I'm going to pause this just 1 second. All right, I just had to look up, make sure I was spelling that right. I don't know why that was bothering me or why I'm having issues. All right, so here's the case. You can do it like we did last time, but here's what a lot of people think. That the identity, so if I want to get back the same thing, now the multiplicative identity in regular math is 1. So a lot of people say, all right, I'm going to let these be 1s. All of these are going to be 1s. Well, take a look at what happens if they are. Right here, I take this row times this column, and then that gives me 1 times 1, which is 1, plus 2 times 1, which is 2. And that adds up to 3. And then if I take it, the row times the column, I get 1 plus 2 again, which is 3. And then this would give me negative 1 plus 3, which is 2. And that would give me negative 1 plus 3, which is 2. That does not give me the same thing. Okay, so this is not your identity matrix. Here's your identity matrix. Now, maybe you remember it. I can't remember exactly everything you've covered in last year. But think about this. What would our matrix have to be so that I get back the exact same thing I started with. I get back 1, 2, -1, 3. Well, here's going to be your identity matrix right there. 1, 0, 0, 1. Because row times column. 1 times 1 is 1. Well, that's what I want, but I can't add or subtract anything else to it, so I got to make sure it's a 0. So that gives me 1. And then if I move over, okay, first row, second column, 1 times 0 is 0, 2 times 1 is 2. So that is going to be our identity. So 1. Now the identity is generally labeled with a capital I. 1, 0, 0, 1. That is the identity matrix. Now, this is for a 2 by 2. For every dimension, you get different. Now, you only have an identity matrix for square matrices. They have to have the same row and same columns. For a 3 by 3 matrix, it looks like this. Okay. All the identity matrix does is have ones down this diagonal, zeros everywhere else. So this would be the identity for a 3 by 3. So only square matrices have identity matrices. Okay, only square matrices have identities. Now it's going to be important because we're going to talk about what's the inverse. Now let A be an n by n matrix. That's a square matrix. 1, 2 by 2, 3 by 3, 4 by 4. Let I be the n by n identity matrix. If there's another matrix out there, B, such that matrix A times matrix B equals the identity, and B times A equals the identity, then B is called the inverse of A. And we write B equals A inverse. All right, now this is the one case. Now we said matrix multiplication is not commutative. A times B does not have to equal B times A, but in this case, if they are inverses, they have to be the same. A times B have to equal I, B times A has to equal I. Okay, so in order to understand what the inverse is, we have to understand what the identity is. Okay, but this is going to be a very, very, very key piece, is the inverse of a matrix. All right, take a look at here. All right, think about this for a second. I got to go take the dog out, so I will be right back. Okay, I'm back. If matrix A has an inverse, a little bit of terminology here, then A is called invertible or non-singular. Okay, so non-singular, okay, it has an inverse. Not every matrix, not every square matrix has an inverse. If it does not have an inverse, we call it singular. Now, you're never going to be tested on that, but it's just good to know that terminology. All right, are these two inverses? Two matrices are inverses. If when we multiply them together, what do we get back? We get back the identity. And you have to be able to multiply them in both directions and get back the identity. So you just can't stop at the first one and say yes. All right, so A times B. Matrix A is 1, 2, 1, 3. Matrix B is 3, -2, -1, 1. Okay, they're both 2 by 2s, so the answer has to be a 2 by 2. Row times column. Row times column. 1 times 3 is 3. 2 times -1. So that is -2. Gives me 1. Move across here. 1 times -2 is -2. 2 times 1 is 2. -2 plus 2 is 0. So that is a good start. Second row, first column. 1 times 3 is 3. 3 times -1 is -3. Adds up to 0. And then 1 times -2 is -2 plus 3, which is 1. All right, that is your identity. So far, so good. A times B equals that. All right, what about B times A? B times A. Okay, flip the order. Remember, it's not commutative. So you cannot assume that it's going to be the same thing. And I got 1, 2, 1, 3. Okay, row times column. 3 plus -2 is 1. And then row times column. I get 3 times 2 is 6, plus -6 is 0. So we get the same number, but the work is different. We didn't ever get any 6s up here. -1 times 1 is -1. 1 times 1 is 1. Add those together, you get 0. And I get -2 plus 3, which is 1. All right, that means A and B are inverses. They multiply together to get back the identity matrix. All right, perfect. Now, that was just checking to see whether they were inverses. Sometimes we want to find the inverse, okay? So let's just work. We're just only going to do this for a 2 by 2, and we're going to use our calculator for higher ones. The matrix A is invertible, okay, which means it has if and only if AD, A times D, minus B times C does not equal 0. Okay. Moreover, if AD minus BC, does not equal 0, then the inverse is given by the following formula. This will be a constant out in front, which will distribute in. So you can take AD, you flip those, and then the B and C become negated. Okay. If AD minus BC equals 0, the matrix does not have an inverse. All right, this is A inverse. Any matrix A. Okay, we want to find the inverse. All right, so let's find the inverse if it exists for each one. So this is A. A inverse equals 1 over AD, which is 5 times 3, which is 15, minus BC, which is 2 times 4, which is 8. And then what you do is you interchange the 5 and the 3, and then you negate the other 2. Now, A inverse is 1/7. That is 1/7, and that is 3, -2, -4, 5. Now go ahead and distribute. That's a constant. Distribute that in, and I get 3/7 minus 2/7, -4/7, and 5/7. Okay, now I'm going to come back to that here in a minute, but let's go over here to B. Well, if we're talking about the inverse, if this is B, we want to talk about B inverse. Well, B inverse is going to equal 1 over AD, which is 12, minus BC, which is 12. And then I flip those and then negate here. But some of you probably already telling me to stop because what's 12 minus 12? 0. You get 1 over 0. Can't multiply by 1 over 0. It's undefined. This is the case here where B does not have an inverse. B does not have an inverse. B is what we call singular. All right, some of you keep going on in college to take some further math courses. You might take something called linear algebra. Linear algebra, it will be all about matrices, and you'll go much, much further in depth into matrices. But let me go back to here. So what does that mean? A, if A times A inverse, since they are inverses, what do they have to multiply together to equal? They have to equal the identity. And both directions have to work. Well, I just want to do one real quick. So 5, 2, 4, 3. You can just pay attention. It was 5, 2, 4, 3 was A. And then we got 3 sevens. We got negative 2 sevens. We got negative 4 sevens. And then I got 5 sevens. Well, you should know what that has to equal. If you know if they're identities, or excuse me, if they're inverses, it has to equal the identity, which is 1, 0, 0, 1. And let me just go through that real quick. What do I get here? What's 5 times 3 sevenths? Well, that's 15 sevenths. 2 times negative 4 sevenths is minus 8 sevenths, which is 7 sevenths. That equals 1. Check. 5, 2 times negative 2 sevenths and 5 sevenths. 5 times negative 2, negative 10 sevenths. 2 times 5, positive 10 sevenths. Adds up to 0 over 7, which is 0. We're golden. 4, 3. 4 times 3 sevenths is 12 sevenths. 3 times negative 4 minus 12 sevenths, 0 over 7 equals 0. And then lastly, 4 times negative 2 is negative 8 sevenths. 3 times 5 is 15 sevenths. 7 over 7 equals 1. And if we reverse the order, we'd have to get the same thing because they are inverses. There's cases where it is the same, depending on which direction we multiply. Okay. B does not have an inverse. Okay, A does have an inverse. All right, here's why inverses are important. Because we do not have the capability to divide matrices. You cannot take B divided by A. So for a matrix equation, here's how we do things. If I want to solve, so this goes back to like 2x equals 6. Well, if you wanted to solve for 2, you can divide by 2, but we can't divide. So what do? Our other option is to multiply by the inverse. Well, the inverse of 2 is 1/2. And so 1/2 times 2 is 1. And then 1x is the same as x. Well, we're going to do the same thing with matrices. And we're just kind of a general case. So we got a matrix equation, ax equals b. I want to get x by itself. Can't divide by a. So here's what we do. So we multiply by the inverse. Now here's a big difference between matrix and then kind of with integers. Because before, like if I multiply on the left here, technically you have to multiply on the left here. Well, you always got away by saying, I can just do 6 times 1/2 and put it on the right because it gave you the same answer because regular multiplication is commutative. Matrix is not. So you absolutely have to multiply on the left-hand side on both of them. Well, the associative property works for matrices. So I can group A inverse times A times X equals A inverse times B. Well, what is A inverse times A? Okay, and this goes to the definition of inverses. If two matrices are inverses. When you multiply them together, you get back the identity. Okay, so A inverse times A has to equal the identity. Well, the identity is like the number 1. The identity times anything gives you back the same matrix. So the identity times X is the same as X. Now, this is the math behind this. You're not going to have to kind of go through these steps every time, but this is basically why it works. But if I multiply here on the left, I got to multiply the B by A inverse on the left-hand side. You cannot do X does not equal B times A inverse because of the commutative properties not true for matrices. So you really, really, really have to be careful of that. All right? So X equals A inverse times B. So here's how we go through this. So now this is matrix A. I'll call this matrix X, and this is matrix B. So that is AX equals B. This is a 2 by 2. This is a 2 by 1. So a 2 by 2 times a 2 by 1 should equal a 2 by 1. Well, we just went through this steps here, these procedures. And the reason we did this is because now, if I have a matrix equation, this matrix that I'm looking for is going to equal A inverse times B. So that means the matrix XY is going to equal A, which is 3, negative 2, 4, negative 3, the inverse of that one, times 4, 5. Okay, equals the inverse of that one. Well, what is the inverse? Now I'm just going to go over here, A inverse. Remember, you do 1 over 3 times negative 3, negative 9, minus B times C, negative 9, minus negative 8. And then you flip the A and the D, and you do the opposite of B and C. And so that gives me what's negative 9 minus negative 8? That is negative 1. And so you're going to multiply that by negative 1. And so I get 3, 4, negative 2, and negative 3. So xy equals the inverse, which is 3, negative 2, 4, negative 3, times 4, 5. And so what is that? 3, first row times first column. 3 times 4 is 12. Negative 2 times 5 is 10. So that is 12 plus negative 10, which is 2. And that's going to be this row times this column, which is 16, plus negative 15, which is 1. So in the end, xy, this matrix equals 2, 1. And since these are equivalent matrices, x equals 2, y equals 1. Now we did this because we can do a 2 by 2 matrix. We're going to start letting our calculator do the work for us. So if you want to know a matrix inverse, so if I go to second matrix and I go over to edit, and I'm going to put in that matrix A, which is a 2 by 2, and that is the original matrix was 3, negative 2, 4, negative 3. If you want to know its inverse, okay, what we can do is hit second matrix. You can just hit A, and then that button right there above the x squared to the negative 1 power, that says the inverse. And there it is, 3, negative 2, 4, negative 3. Okay, it'll spit that out for you. So you got the inverse. You can find that. You do need to know the procedure for 2 by 2. Okay, because I'm going to have you list the details. All right, now this is all this is all background, so that now we're going to use this to solve linear equations. We've done these by substitution and elimination. Now we're going to start using matrices to help us solve these. So for this one here, okay, so you have, what we need to do is convert this to a matrix equation. Here's how we do this. For a matrix equation, your first matrix are going to be the coefficients. Now, even though not all of them have all 3 variables, but all 3 variables show up. So you need to have 3 spots across and 3 spots down. So your first matrix is going to be the coefficients of each of the variables. So that's going to be a 1. That's going to be a 1. Now, if it's missing 1, you put a 0 there. And then there's no x here, so you put a 0 here. The y is a 3. The z is a 1. And then I'll have 2, 3, 3. And now I have x, y, z here equals 4, 7, 21. Here's our matrix equation. Matrix A times X equals B. X is what we're looking for because we don't know what X, Y, and Z are. Well, X equals A inverse times B. Okay, X equals A inverse times B, which means that X, Y, Z is going to be the inverse of 1, 1, 0, 0, 3, 1, 2, 3, 3 times 4, 7, 21. Well, just double check our dimensions. This is a 3 by 3, and this is a 3 by 1. Okay, so you can multiply them together. All right, for 3 by 3s, for these systems, we're going to let the calculator do the work. Oh, this needs to be the inverse of that one. We're going to let the calculator do the work. We're going to let it do essentially all the work. So go under matrix. You got to put it in. You have to go over to edit. And so matrix A is going to be a 3 by 3. And then I'm going to enter 1, 1, 0, 0, 3, 1, 2, 3, 3. Biggest issue when dealing with matrix operations in your calculus, if you put anything in wrong, it's going to be wrong, and it's going to be hard to find it. So I'm just going to double check that I got 1, 1, 0, 0, 3, 1, 2, 3, 3. And it's very easy to miss a negative at any point. All right, so just go put that in for 1. So I got to quit there, and I go back to matrix, go over to edit to matrix B. And matrix B is a 3 by 1. Okay, and it is 4, 7, 21. 4, 7, and 21. Okay, the answer is the inverse times this. Now, I don't even need to calculate the inverse. You don't even need to list it. Okay, here's all you need to do. Go to second matrix. Now, when you're doing operations, you go under the names and you just hit enter. I want its inverse. I can just go times second matrix B, and I'll hit enter, and there's my answers. You can figure out what the inverse is, but I'm going to tell you, you don't have to. Okay, so using your calculator, we're going to let our calculator do the work. 4, 3 by 3s for sure. And what did I get? 3, 4, 3, 1, 4. 3, 1, 4. So what is the answer to that system? X equals 3, Y equals 1, Z equals 4, or the order triple 3, 1, 4. So if you plug those in here, 3, 1, 4. 3 plus 1 is 4. 3 times 1 is 3 plus 4 is 7. 2 times 3 is 6. 3 times 1 is 3. 3 times 4 is 12. Add those together. They do add up to 21. That's our solution. So now you are allowed to use, when it says you're allowed to use your calculator to solve for a system. All right, so do this one. See if you can come up with the answer to this one here on your own. Okay, on your own. Let me just set this up. So when you have a 3 by 3 system, now here's one of the keys though, you have to have everything in order, and you have to have it equal the constant coefficients. Like before, when we were doing it by hand, it didn't matter. It helped, but you didn't have to have everything lined up. Here we do have to have it in X, Y, Z, or A, B, C order. 3, make sure that coefficient's -1. Your Z is +1. 2, 1, 1, and then you got 4, -1, 2 times, and it's always the variables in order as you go from left to right. X, Y, Z equals 1, 5, 4. Now to solve for this, this is our matrix equation. AX equals B. X equals A inverse times B. So X, Y, Z is going to equal 3, negative 1, 1, 2, 1, 1, 4, negative 1, 2. That inverse times 1, 5, 4. All right, now let your calculator do the work. All right, don't just sit there and watch me. Type it in your calculator. I'm going to pause and give you a second. And the only issues with this is just sometimes it's a little bit tedious when you're entering these, but it is a time saver as opposed to trying to work everything out by hand. Again, biggest mistakes occur in just entering, entering the values. And if you enter one wrong, then the whole thing will be wrong. So it's sometimes just helpful just to take an extra second, make sure everything was entered in correctly. And then I'm going to enter in matrix B. You got to go to edit in order to enter a matrix. And then what was matrix B? I can't see it. 1, 5, 4. 1, 5, 4. Okay. And then I can take second matrix A, but we got to take the inverse of it, times matrix B. And what do I get? I get 0, 2, 3. Okay, so X is 0. So we get 0, 2, 3 as our ordered triple. So there's only one solution. This is not one where there's infinite or anything else. Okay, only one solution. All right, that is a huge use of the inverses. Okay, let's keep going here. I'm telling you, B inverse is this value. It says find A if B times A equals this matrix here. This one can be a little bit tricky. This can be a little bit tricky. B times A, I'm just going to let that equal C for a second. I want to find A. I want to find A, which means I need to get rid of B. When you need to get rid of a matrix, you need to multiply by the inverse. You have to multiply B inverse by wherever the B is. So it depends on where the B is, whether you multiply on the left or the right. Here, since the B is first, I got to multiply B inverse times B A, and then I take B inverse times C. Because B inverse times B is the identity matrix, and the identity matrix times anything will give you back the original. So this is how I solve for this one. So now to find A, let me see if I can move this a little bit over here. So that means A, we said, is B inverse times C. Well, we know what B inverse is. It's 1, 2, 3, 4. C, which is this answer here, is negative 1, 3, 0, 2. For 2 by 2, I'm just going to do these by hand. Like I said, it's a little bit tedious for me to type them in the calculator. If I do row times column, and it's good practice as well, 1 times negative 1, okay, it gives me negative 1 plus 2 times 0, which is 0. So that's going to be a negative 1. I get 3 plus 4, which is 7. And then 3 times -1 is -3 plus 0. And I get 9 plus 8, which is 17. So that means that is matrix A. I don't even need to figure out what matrix B is. Okay, you don't need to go through and find the inverse of that. Okay, you do not. We can go through here and figure that out. All right, I'm going to leave you with this last one. See if you can just kind of do this one on your own. Here's what I want you to do. When you submit your homework for this one, I want you under the comments, okay, to tell me what A equals and to tell me what B equals. See if you can figure it out. Okay, so submit that under the comments for this assignment. Okay, see if you can figure out if A and B are inverses. What does A have to be? What does little a have to be? What does little b have to be? All right, see if you can figure that out. Here's your assignment, page 9, 10, 9, 12, 10, 11, 31, 32, 49, 51, 54, and 81A. All right, you guys have a great weekend. If you get to this and let me know if you have issues. Monday morning. Well, no, this is due Friday. If you have issues, you can come to, Canvas conference would be fine, or just let me know individually. All right. Have a great day. Have a great weekend.